So, hi everyone, this is Shivakant. Thanks to Shashank and others for organizing this kind of event, and thanks for joining and making it something successful learning experience for all the folks joining here. So let me begin or resume here. So this is a follow-up session on building data pipeline for aggregation system. So in the last session, we had discussion on how we can build an aggregation system which typically does some kind of bad job. So I'll just jump to that specific section, just a small recap maybe. So there, what was the situation was that we wanted to do daily, weekly, or monthly aggregation of certain events, like for certain business, like a business where there are delivery executive who wants to deliver some items. So we wanted to count like at the end of day how many deliveries are done. So for that requirement, I had designed a system where all the raw events used to go via some ingestion system to raw S3 bucket, and from there on we used to run the Spark job, and finally aggregated events were coming here, and those events were then pushed to DynamoDB for the serving there. And we had a mechanism which was aggregation over aggregation. There was a layer so which was connected from the client via protobuf gRPC, and we used to formulate, we used to get the raw request, like last 3 days of total delivery count, or last week of running average, or reject in the last maybe a couple of hours. So it used to compile, basically compile that and call our range query on this DynamoDB from the serving layer, and then aggregate over aggregate, and finally return the results. So largely the tech stack most of people can understand. So this was largely the data model, that hourly buckets were there for a given delivery executives, and all the different hours were there. Now for simplicity, let's say I want to aggregate for the last weekend, so I can just put those days, basically day and that delivery ID, and finally the day and actual date here. This is a partition key, this is a sort key, and I could get all the attributes that I'm interested. Let's say delivered count, rejected, or logged in minute. I will pass as a parameter. It will return me that, and based on the type of specific events and aggregation supported, we can just say sum this thing or count this thing, or add this up. So that is how it used to work. So far this is good, but it has one limitation. I mean, this is a bad job. So this is a limitation that we cannot do it for a very small granular aggregation time windows. Like this is not suitable for 5-minute 10-minute kind of window, where the Spark job itself is still running, or the events could be laggy, and the scheduling could have some delays, right? Maybe 30 seconds or 1 minute. So it actually enforced us to build a completely separate system to achieve this thing. So I'll just jump to that specific scenario, and I'll explain what actually was the requirement. So we wanted to achieve some sort of incentive target, like X order away from an incentive. So in a given running day, let's say that we want like on the 10th order, we have 50 rupees or 100 rupees of incentive is there, or from the US perspective, maybe $10 of incentive is there. How do we motivate a given delivery executive there? So this could be applied in any different model of aggregation that we had specific requirement, but this kind of is a platform kind of thing that could be used anywhere. So similarly, like if there are any delivery executives who are doing some long distance deliveries, so can we capture those specific attributes and then notify the downstream, basically? So this was basically a simple architecture for this. So here all the input events were coming to us, like the Kafka event. Let's say the reject counts were coming, like if we are getting more than 3 rejects, then we will basically notify the delivery executive that, hey, you had 3 rejects today. If you do one more, you will be penalized this amount of money. So what used to happen was we directly used Flink as a platform there, and Flink actually supports window level aggregation, for example, last 24 hours or starting from some point of time. And it also supports like once that some sort of criteria filtering, like I say that on this aggregate, if the criteria is matched, then only pump that event to the downstream. So it also supports calling certain user defined function outside the scope of the Flink to get the job done. So some of the criteria is like what should be the threshold, like when should we notify about incentive or regarding some penalties. So this was basically the simple setup that we get the event, we will configure it with Flink, and Flink will, once the rules are qualified, then the underlying pre-aggregated events or the results would be pumped to the downstream. Once they are pumped to the downstream, it can be further used for rule execution or direct notification. So this was kind of a simple setup here, and yeah, so this is kind of this makes sense. Like the Flink out of the box actually supports this, so we were not required to think beyond this. Like we just had to configure it, and it was working out of the box. Yeah. So any questions on this, or any question on the requirement, what at least for real time streaming here? Yeah. So one thing I want to add. So in our previous organization, actually there was a platform team who was managing the Flink as a wrapper, and we used to call it as a rail. So the thing is, we had certain concerns on what should be the fault tolerance capability, recoverability capability, and replayability. So all those things actually the platform team had promised us that they will take care of us, that we will just interact via API. So that's why you might see that this is little much more high level. We were not required to actually drill down much here as part of this implementation or or design here. So I'll yeah so anything else? If no one has question, I will just drill down here, and I'll jump to the last section of this, and we'll see if there are any further follow-up question, and then we'll close. So the components are input Kafka stream events. The Kafka will contain raw pre-agreed in pre-agreed form certain events, like the order status update events of the delivery executives. So for example, like it will have delivered as one event type in a given topic. So we will listen to that topic. We will basically connect that topic to the our platform, and it will listen, and then we will have filter that where event type is this, do this aggregation and do that aggregation, and finally pump out the result here. And then there will be some sort of notification system here, which will let's say it is 7th order or 8th order, just below the 10th order, we will just notify, hey, if you finish 10th order, you will get this kind of incentive. So one good part of this was that accuracy is not of a very big concern. And so while we are messaging on the 7th order, if it gets aggregated to 8th, it's totally fine. I mean, this is just some sort of notification or triggering. It will typically not handle immediately the financial thing. That will be processed separately. Like incentive actual calculation, this system will not handle. So we have some level of lag here, and we have some level of reliability, and a little bit miss on calculation is also fine here. So the next part of this component of this platform was the Flink as a underlying platform itself. So we Flink actually it supports some sort of SQL based query, where we ingest something, and then we write some query. It will process that query, and then it will do the evaluation. And it also supports user defined functions. For example, we want to filter out certain kind of delivery executives and things like that. And these UDFs, they support REST or gRPC. So like integrating with anything is like kind of pretty obvious or doable. And output Kafka stream, it will dump all the processed events. So here basically basically not processed, but filtered events for further processing. So this was the model, and kind of, yeah. So now so this so that's it about real time, aggregation or streaming. uh, for our scope, because it was a platform, we were not required to actually go and drill down into how actually it works in the Flink, or how the in windowing happens and all. So those are for further reads, not required at this scope, kind of. So does that sound good? Shall I move to the next scope of discussion? Okay,
Yep.
so I'll assume that we are fine. So now the next set of thing is, so we had this pipeline where we had aggregates, like mostly like let's say like daily, weekly, monthly kind of aggregates as a bad job. We were here, and there was a requirement where we wanted, some sort of lifetime aggregation here. So how do we achieve that? So we have two different systems, and they have their own limitations. So regarding the Spark pipeline, we already talked about the limitation there is that it is not very suitable. That is a bad job, and it is not very suitable for, like minute level of granularity, or yeah. So it has certain lag maybe, and that's why we only do hourly aggregation at the lowest. So, and then we have the other one, which is the real-time pipeline based on Flink. So there it does the aggregation, but the limit that also has a limitation. Like it cannot be unbounded window. Like I cannot have aggregation running from lifetime, or I cannot have 1 month long running windows and storing the data. So typically, couple of hours or up to 24 hours is something practical here. So now the goal here is, how do we get some sort of lifetime aggregation? Let's say what is the total deliveries done right now, not till yesterday. So till yesterday can be directly processed by this Spark batch pipeline, right? So what I can do is, let's say I have all the monthly aggregates, and I give a range query, from let's say this engine started in 2000. So I'll just say from 2000 till today, or like maybe 23rd of Jan. So what it will do is, it will break it into year, then it will break it into month. So month is not applicable. It will break into weeks, and it will break into days, and probably hours, and then it will trigger like this layer basically. So client will pass the range, it will trigger, and it will split the query and fetch the raw data, like pre-aggregated data from this batch table, and re-aggregate. So it's aggregation or aggregation. So it will be able to come up to maybe a daily level or hourly aggregate. So what about the last bit of piece? So last bit of piece could come from the secondary aggregator, where this real-time aggregator, like what it will do is, it will fill some sort of hourly buckets. So we will have hourly buckets where it will just aggregate and put those values here almost for ready serving. And then so just the last hour, it can fetch from this bucket and finally calculate and return. So with this, we can get like lifetime aggregate value for almost like anything and everything. So this architecture at least makes sense. Like does anyone has any doubts here? I have definitely zoomed in, but if someone feels I should zoom a bit more, I'll just do it a bit more. So is it more clear here now?
So what is this batch table DynamoDB? So like,
Yeah,
no?
yeah, sure. So this is basically a table where we are keeping all the results of batch aggregation. So it will have like daily, weekly, monthly, all the aggregates for serving purpose. So we cannot have we have raw data on S3. We have aggregated our data on S3, but S3 is not suitable for serving. So that is what is coming from this pipeline to this. So this is basically a huge compression of this architecture actually. So what we are saying is, this whole part is the architecture, and this is your table, DynamoDB batch table. So it will have, right? So compacting all these things into a single box, and just the last thing, which is serving layer, that we are talking about. So that is what we are seeing here. Make sense? Yeah, go ahead. Feel free. I can answer.
It will be some sort of key value pair, right, in the DynamoDB.
Correct. So it's a wide column data store. So we will have a schema, something like this. At least it is very detailed here. That like for a given day. So DynamoDB has partition key and short key paradigm. So I think Cassandra also has the same
Same,
kind of
yes.
yeah. So this is a wide column data store. So why we chose wide column? So couple of things. So just to talk about maybe trade-off if it was not very obvious. So earlier the same things were happening in relational DB, and what was happening is whenever these jobs were running, it was hitting the main database really hard. So every morning like 5:36, this was running from the table. Hey, sorry, I think there is electricity. My in my area is gone. I'll have to reshare my screen because you might not be able to see. So at least are you able to hear? I'm fine to continue.
Yeah.
Yes.
We can
Share.
hear you. Yeah. Sorry about that. Yeah.
Yeah. I'm totally fine. So this is my
We can see it now.
yeah. So this is my monitor basically. So laptop. So here now. Yeah, so you might have a slightly different view here. I'll just zoom out a bit because this is a smaller screen. So yeah, so here the earlier, so we already had a business running. It was running on really large relational DB MySQL, but the problem was the cost associated with that. And every time the number of users started increasing, this used to take huge amount of time, and we had to double our boxes. Maybe M4 4x large, M4 8x large, 16x large. So how large can we go? And it started becoming really expensive. So that was basically the motivation, that can we build a separate system for aggregation rather than running all the analytics or aggregation job on the relational DB itself, or on the same relational DB, maybe other table but same DB. So that was actually the main motivation here. So now we had couple of options. So one of the option was like, can we use time series DB? So that was serving some of the purpose, like use of influx DB also we had proposed. So I had proposed. So that was serving some of the purpose, but some purpose were not met. And so we finally thought of buy versus build. We thought that, okay, we will build this. So here we had couple of options. One was, can we do it directly with S3? So as an object store, but it has latency issues. So can we use maybe a key value store? So key value store uses everything as a hash, but here our requirement was, for a given key, we also wanted some range of values. So like white column was much more suitable, and white column has very high write throughput. So especially what happens is this will have so many aggregates, right? Let's say that in a given day, we will have 24 hours of aggregate. Are all those aggregates even needed? So I might have to just reshare my screen. Yeah, if it happens again, I'll just break and connect again. Is my screen visible by any chance?
Yeah. You are visible. The desktop is visible.
Achha. But the screen is
The
not.
wallpaper.
Okay.
Yeah.
Okay. Actually, my screen is switched because of power. So in case it happens again, I'll just stick to one and complete it over. So so here yeah. So there were a couple of trade-offs possible. I mean, options were there. One was time series, reuse of relational key value pair, and white column. Couple of things that really fit us well was that we already had some expertise in DynamoDB, and we wanted to use like a serverless kind of solution where we don't have to worry about maintaining that thing. And we wanted to do range search here, and we wanted to do a lot of write throughput, basically a lot of writes here. So and during the serving time, a lot of reads here. So now DynamoDB actually provides read some RCUs, basically reserved reserved read capacity unit and write capacity unit. So that way we can adjust the pricing as well. So, for typical scenarios, we can just bring down the read and write to maybe 10 TPS or QPS. But when we are actually running some sort of batch job for write or read, we can, make it very high or maybe auto scalable. So that way, a lot of, platform related, pain were transferred to the underlying, serverless solution, and we were able to concentrate on building the solution. So this kind of served us really well. So if I compare with Redis or any key value pair, then we would not have got this, range key. So we would have required to call, let's say I want last 7 days of data. So it would have required calling 7 times Redis get or something like that. So here a single get with a range of values or list of values, it can return everything, and then we can aggregate on that. So now does it make sense how's the data model and how we can run aggregation over aggregation? Like I get like for one day like 4 delivered count. So I'll just accumulate all those and kind of return it back to the end user. So like this was kind of query model, like we have a sum of delivered count. So whenever I provide a date range, let's say 2 days or 5 days, so whatever values are coming, my microservice will sum them up. So yeah, so that was kind of operation over operation. So yeah, so this I'm jumping here back to this thing. So this is the big box that we had created, and this is the serving layer. So here for the lifetime aggregation, it will require triggering from both these table. So yeah, so that's I think.
Yeah,
So any other question?
Yeah, one question here. See, now maybe it's a very basic question and not a relevant one. So you have these two pipelines, right? One is the Spark pipeline and the other is real time. So when you say real time pipeline, is it almost a real time? I know it can't be real time, right? It will be near real time or almost real time.
Okay, so what I will ask you a cross question. What do you understand by real time?
Real time is exactly at that time what you are getting in a time deterministic manner. Maybe it's like a microseconds, something like that. You can respond that. Or so okay, for let's keep that aside. So if it's real time,
for me, real time would be calling function call.
Yeah, almost like that. Okay, let's keep that aside. Okay, in this scenario only. So if you have Sparkline, it's almost like a batch job, and this is a real time is happening. I understand there will be a processing will be more quicker than the Spark pipeline. But now if you have already all the data from real time pipeline, so still do you need the batch processing, because these data will already be available on the real time pipeline now, right? So you can store that and again get those cache data back.
Surely. So I understand. So let me kind of answer the first question as well. So what is a real time? Real time is always on best effort basis, and there is no true real time system that anyone can build. So that is not possible, because when you are getting an event, you run some logic and then you react. So whenever you are running a logic, you are delaying there. So it's not real time, right?
Mm-hmm. Yeah, I got that.
Yeah. So you have, if you are able to react immediately, then it is a real time. But that's not possible, because then you have to do it in 0 millisecond. So that would be an immediate reaction. But if you are taking 1 millisecond or 1 nanosecond, then you are taking some time. So always real time, although is a very a kind of niche term that we talk about, is always near real time only, because there is no such thing as real time. There will be some compute, there will be some read from cache, there will be L1. Even for nuclear power plant, they will have some SLAs. Only the SLAs will be smaller and smaller. Like
Can I make a comment here?
Why not? Yeah, it's an open discussion. Yeah.
I think the meaning of real time is not like 0 second or very low latency. I think the meaning of real time is, the definition of real time is something, a guaranteed time. It can be 1 second, 1 day, 1 year, but it's a guaranteed time.
Yes. So basically we were talking about the SLA. So here, like what I can say that suppose I'm I'll just put it here, real time. So so let's say for the real time, we can have certain SLAs. So like for maybe nuclear power plant, I can have an SLA
Well, okay,
of
okay.
maybe,
I really don't want
yeah.
to,
Yeah.
divert
Yeah.
the conversation there. Frankly, it's
Yeah,
not
yeah,
about that definition of a real time.
yeah,
Yeah, that's fine. Okay,
yeah,
what I'm saying
yeah,
is, so
yeah.
whatever you are getting all the data from the real time pipeline, because you are doing much faster than the batch job processing, right?
Correct,
So
correct,
is
correct.
this so all this data you can easily cache and then get, instead of using that Spark pipeline, you can still get that data from the cache values, isn't it? Or am I
Yeah. Sure,
wrong?
sure. Yeah, no, no, you're right. So let me go there. So now, what is the thing? There is that uh, now this real time aggregation, whatever is happening. So first of all, there are. I mean, just to bring everyone in loop, there are always lag in the system from end to end pipeline. For example, there is an app, and from there you are pushing an event. That I delivered this item. So as a human, you clicked it after 5 seconds, right? So that is a delay that added to the real-time processing engine end to end, right? So then it went to your Kafka. Kafka will do some batching, producer level batching, consumer level batching, and it will go here. So there is already a lot of time lost. So having really tight SLAs on those, real time would only be useful when the business is it's very critical. So that's why we can have larger SLAs for this thing. Maybe, can we say that here it is like, 10 second is just fine, and it is a real time for me. So now what this guy will do, and why it cannot be simply replaced is this will have only, so here I had mentioned like 15 minutes bucket, but for simplicity, let's say we will only have hourly buckets here, just to make everyone on the same page. This guy will do up to daily aggregation, and this guy will do up to hourly aggregation. So what it will do is, every time the events are coming, whenever the ticker flips in the backend server, it will, instead of dropping the aggregates or the water on that R bucket, it will move to the next bucket. So now what is the problem here with this? So one problem here with this is the accuracy. So what could happen is, some of the events, although they are so there are two timestamps here. One is arrival time, and then there is the event time, right? So here we can never aggregate on the event time, because what will happen is that a certain set of events could come delayed, right, like 15 minutes later. So we don't want to disturb multiple buckets here. So what we can do is, I mean, for being simplistic, we can just, whenever the event arrives, we can have a cutoff that it has to arrive within that stipulated time, with maybe 2 minutes of extra delay. Like, we start our session maybe 10 minutes. After that, we will not fill the bucket, we will move to the other bucket. So here, always the accuracy is always a problem with this. Like, some events can get stuck in the Kafka, or sometime this platform is loaded and there is running 10 minutes of lag is running. So this will not provide very accurate result here. So this pipeline will be very useful, where at the end of day, after 30 minutes, we can start the aggregation. So we will have at least really breather window to aggregate these things, right? Now what happens? So accuracy is one thing. Now other thing is, here we have multiple aggregation levels, right? A daily, weekly, monthly, and probably yearly. So now if I want to ask you, what is the lifetime value on this real time table? So think about it, in a given year, how many hour bucket I have to aggregate on aggregate. So it will be like 24 hours into 30 into 12. So that will be thousands of buckets
Yeah,
that I will
it's
have to
huge.
pull and aggregate. So that is actually the core reason why two different things are required here.
Okay.
And yeah. So
So yeah,
accuracy
the
and
real-time pipeline actually is trying to address a very current scenario, or maybe it's like a dirty way of doing it, but you have something to do at least, right? Yeah. And it is bucketized, so therefore you can't get a very good resolution in that, right? So therefore you still have to do that. I got it. Yeah, no worries. Yeah, thank you.
Yeah. So I hope everyone is in line with this, right?
Yeah.
Okay, cool then. So that way, so that was one part of it. So another part, I mean, we intentionally didn't do was here, whenever we are building aggregation over aggregation. So simply saying, for example, I want for last 70 days of data. So what we will do is we will break it into months, weeks, and days, and then we will calculate. So what happens is this is very easy to explain to humans like us, but actually this is not algorithmically the best approach. The best approach would be maintaining some exponential aggregates, like let's say R is an aggregate, or let's say simplicity day is an aggregate level, like the very smallest quantization of number. So we should store 1 day, 2 day, 4 day, 8 day, 16 day, 32, 64, 128 to 56. So that way, actually, it will require minimum scan on this table. But the problem with that is it is very hard to explain to someone, and that range query problem is like little complicated to debug. So that's why we went ahead and implemented a simplistic model here. So yeah, so hope kind of this trade-off also people will agree. So here, yeah, so the caveat we provide here is like whenever someone is asking for lifetime value, we will say that this will have little accuracy challenge could be there. So if you are fine with 1 or 2 numbers, then we will provide that. Let's say if someone reaches the 100th delivery or 1000th delivery, and actually it was supposed to be 102. So I think it's fine, right? It's not that much, really bothering. Like correct, like the person is already delivering 3 orders while he did 102nd order, he or she. Actually the system notified that hey, your 100 deliver order got successful. Congrats on achieving. Because anyway, the person will do it, right? So makes sense, right? The criticality of it. But this typically this should not be used for actual payments. This could be used for maybe notification, something like, hey, you achieved this number, and anyway, if we achieved here, for sure, whenever we do offline processing, it will always be here. This is more accurate, right? So yeah, so hopefully this makes sense, right?
Yeah, because see, someone is doing a 103rd delivery and he's getting notified that he's just 100. So other 3 deliveries might be in transition, right? So that's fine.
Correct. Yeah. So that is basically near real-time aggregation that we are talking about. Okay. So yeah, and so now if someone says real-time notification, I mean, why I'm really being nicky-picky there. I'm not pointing out to anyone, just I'm being nicky-picky there.
No, that's fine.
Yeah. So if someone says I'm building a real-time notification system, then they have to transfer that information from the backend to my mobile immediately. Immediately means 0 time, not even light of speed of light, which is very slow. Okay. I would
and
say
that's not possible also, right? Because you need a lot of infrastructure resources.
Exactly.
And it's very expensive. Yeah, I agree.
Yes. Yeah. So similar, so a very similar term which sounds very vague is elasticity. So elasticity is like people say that, okay, I want to scale my system quickly so that I can take up the load. So elastic systems are again kind of reactive or proactive we are building, not in this context, any general context. So there, when someone says that my system is elastic, so my cross question would be, is it 100% elastic? Like is when it is seeing the one more event, is it immediately scaling up the new machines? Not possible, right? Because the EC2 might take 5 minutes to come up, or Kubernetes pod might take a couple of seconds to come up. So that is the elasticity gap there, and that is the real-timeness gap there that we call near real-time. So just
considering the volume, it is actually right? If you consider the volume, what you are processing, it's near real-time or real-time, whatever you call, or maybe elasticity. It makes sense. Because if it's a smaller volume, like you have only 5 or 10 things to take care of, it's much easier. And you can attend that microseconds and whatever that is. Well, okay, my question was really not on that, but it was only how the difference is between the real-time pipeline and your the batch one.
Sure.
I got
So,
that. No worries. Yeah.
Yeah, hopefully I answered it. Just I was
Absolutely.
going here because this term gets used very much, and
Yeah,
I
absolutely.
mean,
Yeah.
anyone might think that okay, what will be the scope? So it will be with certain kind of uh, guarantees only. We cannot get the full thing. So this is actually one of the internal implementation, like how we will connect the different things, like how will the rule engine communicate with the DB and all. I think it is not very much useful. So yes, I'll just maybe jump to the final thing of it. So so I hope the this part, basically the batch aggregation and real-time aggregation, it makes sense here, right? Okay, so I have one last bit of piece of information here before we close for the day. So this was again a sort of aggregation requirement that was asked to us. So so that was basically let's say that every morning at there during the login time, 5 minutes before, I want to notify the user, hey, wake up, time to get ready and go to your starting location. Let's say I'm I'm living in some location in Bangalore, maybe Halsuru, Murphy Town, and I have to start serving from Indiranagar, where actually from morning 7, some deliveries start coming up. So I should get some sort of notification. So similarly, there are so that could help the bring the productivity up. So so the goal here is actually, every time these days human resource are the most limited resource here. Technology we can scale, we can SMS, we can build such infrastructure, and that is what we tried here. So now another question was like how much a person has tenured in the system. So the goal of this was that, let's say that the person has completed 1 year. So how can we notify them that hey, you completed 1 year via work anniversary, or maybe can we capture their birthdays? Similarly, like if they are into the first week of it, so can we notify them to complete the training session, that hey, go ahead and complete this part before you do your first delivery and all. Or some statuses also, like we can do some sort of scanning, like there are delivery executives who haven't logged in from last 1 month. So can I mark them as inactive? So we can have some sort of jobs that will identify these delivery executives, and notify them, hey, if you stay longer for 3 days inactive, you will be marked as absconded, and whatever remaining money is there will be forfeited. I don't know. So basically those kind of things, it could be notified. So so for the purpose of it, this was kind of the high level architecture, that all the like whoever wants to schedule an event, they will first of all they will configure those events from using microservices. Not here, I think somewhere it is not clearly shown. They will configure the events, and it will be stored in the DynamoDB, and then it will be scheduled via this so we will have some sort of scheduler here, not very much elaborated here, but we will have some sort of scheduler which will listen to these scheduling events, like log out events and something, and then it will run some sort of batch job. So let's say that I want to notify every morning at 8 a.m. I will run a batch job. So there will be a scheduled event running every day morning 8 a.m. It will run a batch job, sprint batch job, which will scan through all the delivery executive DB, and finally from here it will serve the delivery executives, and it will fetch who all are qualified to be having a birthday message here. So from here it will pull those details, and then finally the using some external service, internal service, it will build the messages, and then it will pass on to the notification system. So this is again architecture level, not too much of design details have been mentioned here, and all these things could be independently a sub feature or sub design we can have, like scheduling event. I've been building a scheduler itself is a system that I have also presented in one of the older sessions. And similarly, we can have some sort of notification system. So this also, like in any system design, we talk about how do we build notification system. So we can have those kind of systems here, and similarly other parts of it. So here using this, the combination of components, and maybe like the scheduler. So we, at that point of time, we had thought that we will use Quartz job as a scheduler, but now at least like last time I discussed, now we have more solution that we can evaluate in our future implementation. We can have custom implementation. We can have we can also use probably Airflow or some advanced timers rather than Quartz. So the problem with Quartz is it is it runs on VM. So what if what if the VM goes down? So we'll have to actually think about it. So that is not actually covered here. So in my one of my presentation, I have talked about what if the VM goes down. We can have some sort of warm up where it will pull all the scheduled jobs, and it will again build up the quads in the VM. So it is not detailed out here, but yeah. So we can you can take it from there, and then here for serving we have DynamoDB, where the messages and all the metadata are available for the delivery executive, like hello, this is your anniversary, have a great day. How what that those kind of messages we can store, and then like a message interpreter service which will convert. There will be some sort of templates, like for the Python people we have Jinja templates. Similarly for Java there is a templating engine. We can use that kind of templating engine, and just fill the placeholders with hello, and that dollar will be replaced by this, and then a communication service will finally do the delivery. And yeah, so these are basically the events we can notify: anniversary or first day, some sort of scheduled job of that kind. And this is one of the sequence diagram, like tenure for ZB. Yeah, so just 1 second. Yeah, so here one of the sequence diagram has been stated, like a quad job will run, which will pull all these with certain joining date. Let's say that I want to pull who joined 1 week back. So I'll calculate current day -7, and it will return those specific days. So here again, we can model the data in such a way that we get paginated list of delivery executives. And from there, we will run specific queries. We will create the message, messages using message interpreter service. So here we will pass on this delivery executive data and the template ID, which is configured for that job, and it will create the actual messages like filled message, and we will finally trigger that via communication service. And if it is some sort of push notification, it can directly push it to their app, and they will get the final goal done. And yeah, so finally this is how kind of we achieved this. And yeah, so does it make sense, at least the sequence diagram? Any question on this? Am I audible?
Yeah, you are audible. Yeah. This is more of a implementation specific, right? Yeah.
Yes. It is very implementation specific. Yeah. So yeah, you can vary it. Yeah, I totally agree. Like so like some of these pieces, so this is like a high level building block. Some of these pieces you can always zoom in, you can replace, you can think from a different perspective and all. So that is always possible. Yeah, so this is one, maybe you can take it as a reference, so to say. So yeah, so with this, actually
a lot of efforts you put in this. Yeah.
Yeah, thanks for the appreciation. So New Relic, Prometheus, and for scaling we basically justified that all these things like Kafka, Flume, Dynamo, Spark Job, and all these things wherever are running, they are like typically stateless or horizontally scalable, and it will serve the purpose. And there will be we will make sure that there is So there were some thoughts about how do we do multi-tenancy and all. So for some of the systems, we had built a multi-tenancy messaging system and all, but at that point of time, it wasn't matured. So I don't have much data point there. So yeah, so this is largely the thing that I wanted to present as part of two session, building data pipeline for aggregation system. And I hope it was useful. So definitely I can maybe share the diagrams, not the document, because it's an official work that I did. So diagram is like pretty agnostic. I don't see any issue in sharing this. I can share if required.
Mhm.
And yeah, it can be taken as a reference and it can be enhanced and things like that. So yeah. So that's all from my side. Any other question? I keep hearing some newer design problems like top K, top K in the leaderboard, or I want to aggregate and Google Analytics. So I've been discussing with some of the folks. So I think some of these experiences I had was definitely useful in coming up to a good level, maybe 7 out of 10, and then can I ramp up 1 or 2 more points towards almost the ideal solution is always my thought here. So yeah, so I hope the same presentation or the reference could help you with this knowledge. And of course, any feedback, like if you feel that okay, no, this could be done in a different way, I'm ready to take that, yeah, as a suggestion. Yeah.
Well, not a feedback, but yeah. So whatever you said about the top key and all that, they are more generic, right? So
Yeah.
your is more detailed,
Yeah.
whatever you presented, and it's
Correct.
very
Correct.
different.
Correct.
And
Yeah.
it gives a perspective of how you can use batch jobs and how aggregation works, in a detailed way.
Yes.
So I
Yes.
really
Yes.
appreciate your efforts here. They are really wonderful and awesome. Yeah. And also
Thanks.
when you
Thanks.
said,
Yeah.
you want to share your diagrams, they might be proprietary to your organization. So I would say if you could abstract some of them to a very high level, that should be
Okay.
fine. You don't have to do all this stuff.
Okay.
And if anyone wants
Okay.
really
Okay.
working on something and he wants to know really details, he can get back to you. So that will be a
Yeah.
better way of
Maybe at
doing it. Yeah.
individual level.
Yeah. Yeah.
Yes. Yes. Reach out to
So
me individually
yeah,
for
because
with your
we don't
proposal.
want
Yeah.
you
You can
to
come. Yeah.
actually be in a legal issues, because nowadays it becomes very problematic. So be careful. Yeah. 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 Absolutely.
Okay. Okay. Sure. 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 Yeah.
Yeah.
Thanks.
Yeah.
Thanks. Yeah.
Yeah. Yeah.
So
That was good.
yeah, thanks. So anything else? I hope if anyone has question, and I'm there for maybe 2-3 minutes. We can discuss it.
So there is
And
no,
just
is there any
maybe,
bottlenecks in the system, like single point anywhere, like database or anything?
yeah, surely. So let me think about it. So far we had benchmarked this part. So here we were able to run 5,000 events per second, the Kafka. So let's iterate through this. Kafka typically, if we have a given partition, I think can give 100K QPS. So a single partition is like highly scalable. Next is Flume. So this is a purpose-built ingester. So on a single node, we were able to get 5,000 TPS here. So what it was doing was it was getting some batch of 100 data from Kafka, and it was converting the events and writing to S3. So this write was giving 5,000. So this had a limitation, at least in our setup. It was not horizontally scalable, but a single node setup it was. So for legacy reasons. So now going to other components, like S3 is like, again, like really infinitely scalable. So again, that infinitely is subjective, right? When we say it's elastic or when we say real time, so it is always subjective. So, or even durability, when we say acid durability, that is always subjective. Nothing can be 100% durable or 100% consistent. So here, like we can have hundreds of Spark. Let's say we have hundreds of Spark, nodes here, and basically executor here, and can they pull all the data from here and pump it here? That is possible always. So so this is like, there is theoretically this will be massive. This is massive, and this is also like this was only the part that was here of the Dynamo was the price. So far they had mentioned like you can easily scale up to 40,000 queries per second, 10,000 writes per second without much issue. So for our scale, which was like maybe 10 million events per day, and going up to maybe 100 million events, this system actually was kind of perfectly suitable here. So every system, at least what we had benchmark, we were getting like 5,000 TPS here, and the rest of the system are anyway designed to be scalable. Here also we ran 100,000 and up to 5,000, and it was working. And for this component, we had done some optimization, which was instead of REST API, we had in the org level, we innovated, and one of my team member, he went ahead and created adapters for gRPC and protobuf, and we basically aligned to it. So yeah, so that gave like almost like 10x improvement over REST APIs. So yeah, so largely that's the thing. And so not majorly a bottleneck for 10 to 100 million events in a day. If we think about a billion events, I think we will have to think about it. So this would be a deprecated component. This will not be the right fit. We'll have to think about a more modern solution. I think Kafka is something that we will have to trust. Instead of 1 or 2 partition, can we have 100 partition? And S3 again, we will have to trust. And I think most of the components will work. Maybe Dynamo will throttle there, and then we'll have to have our custom Scala cluster, maybe really large machines with let's say 128 cores or something, and vertical machines, and can they process 100k QPS or 500k QPS kind of queries. So that is something in-house the company will have to make beyond DynamoDB scope. So I think these are something that will come up if we are reaching the billions of events per day, like maybe Uber scale or Google scale. So yeah, so that's largely about it. Anything else?
Hey, just one question. When you're discussing about QPS here on DynamoDB, how much is the upper limit you said? Roughly.
I think yeah. So what I read, 40,000 QPS. I think we can check it. It should be public, and
okay,
it has
40,
nothing to do with
around 40,000.
Yeah,
Okay.
40,000.
Lesser than 100,000. Okay.
Lesser than 100,000. That is what I know. Maybe someone can check it quickly.
Okay, no worries.
Is there
I
any
thought, yeah, it's
limit?
fine.
Yeah. Lesser than 100,000. That is what I know of. Yeah. Let me just check. Okay, if I flip, actually, my screen is going away. So
Don't worry.
So some of these components have to be changed. I know of these two have to be changed. I think we will have to live a lot longer with Kafka. Like if we are getting 100k QPS per partition, and we create 100 partitions, so we can get 10. I mean, theoretically, we can get 100 million, 10 million events per second. I think that is pretty massive to live with. If we try to design ourselves like maybe Redis queue or something, I think it will bring in more headache rather than solution. We will definitely get a really low latency thing, so that might be useful for crypto trading, algorithmic trading, or stock exchange. But anything beyond that, I think is an overkill. Again, that real time word comes catchy here. Like someone will say, yeah, I want to build a real time crypto trading. So so there we can say, okay, Kafka might be giving me a couple of seconds of lag, so let me build some in-memory queue here, and this ingester will kick out, use some new technology. S3 will be too slow for those kind of things. So, and of course, none of these will work. So anyways, that is a topic of different days discussion. But just if you think about scale, this we will have to rely. I think S3 we will have to rely. I think no one will deny that, hey, can we replace S3 with something else as a data lake or raw bucket? And again, I don't think there is a better alternative to Spark for doing a bad job. And we have a Spark 3, which is really awesome. So yeah, and for serving, we can replace. I think again, for gRPC, there is no better option for this. So regarding algorithm, again, we will have to upgrade the algorithm. Our daily, weekly, monthly will not work. We will have to pick a lowest granularity. Let's say your business is interested daily. Just pick day as a quanta, and go and do a log buckets. Like instead of day, week, month, just store in 2 days, 4 days, 8, 16, 32, 64, and that way build using, I think, Fenwick tree or some binary index tree. You will have to use that algorithm, and that will be like top shot solution for this. So hopefully impressive enough for Uber and Google. So I'm just thinking that way. And yeah, so that's largely the scheme of things I have. And just to reiterate, here we will have only a single bucket. Now someone might ask that why can't I have running buckets for daily, weekly, monthly, yearly? So the problem with that is, let's say suddenly this system goes down or this DB goes down. How do I repopulate, right? We were having yearly bucket. Now do I have to run for whole of the year through this pipeline and build? I think this will be a big mistake, right? Especially at the serving layer. And of course, I cannot keep it in data lake with a level of 9 durability. But this part is stored in both the raw part, and the aggregated is stored in S3, which provides a level of 9 of durability. So if something goes wrong, like hopefully Dynamo will not go wrong, but let's say we chose Scala or an implementation of Scala. So let's say Cassandra, let's say that it goes down, like all the 3 replicas goes down, we can take some downtime, and we can anyways repopulate from this source, and we will be up and running in whatever is the kind of data that we have. So yeah, and those buckets will be really pre-aggregated. Yearly will be just one entry, right? So it can quickly come in here. So it will not be huge. Like let's say it can be recovered in 5 minutes. So yes, this could be recoverable. What about recovering this in 5 minutes? Probably it might take days if we want to really maintain all these buckets. And some mistake happens, we cannot rerun this. Basically, there is because it will destroy the previous aggregation. Here it is pretty easy. We can just flush the target bucket and repopulate. Let's say a lot of events were stuck in the last 1 hour. That is what we face in the org, right? So we can just say, hey, shit, this happened. So let's rerun this job again. Let's flush this and rerun this, and automatically more accurate results will come, especially if we are getting too many complaints and things like that. So we can handle it. So yeah, so largely that's the thing I have to present and maybe just reiterate. So I'm just stopping my screen here. I'm just still open for any further take on this. And yeah, so I hope you found it useful, and you could use in your organization or elsewhere in this format, or maybe some other form.